Hello students, I'm ready with my next video. You all watched my previous videos, thank you for that. Today's video number 4. And this time, last 3 videos were on English. This time I decided to make a video on mathematics. And the topic is Introduction to Trigonometry. Introduction to Trigonometry. This is very important. Grade 9, grade 10, grade 11 and 12. For these students, this topic is very important. Introduction to Trigonometry. Trigonometry is a branch of maths, just like algebra, arithmetic, geometry, calculus. Then one branch of maths, another branch of maths is trigonometry. Trigonometry is another branch of maths. Trigonometry. It is made up of 3 words. Gono, angles, angle, metry, measurement. Angle measurement. Why it's like that? We will see. Now trigonometry. This trigonometry has 6 trigonometric ratios. Those 6 trigonometric ratios are sine, cosine, tangent, cotangent, secant, cosecant. 6 trigonometric ratios are there. Now question comes, why there are 6 only? Why not more than 6 or less than 6? What is the reason that we have 6 trigonometric ratios? That is because trigonometry mainly depends on right angled triangle. Trigonometry depends on a right triangle. We all know that a right triangle has one angle, right angle, that is equal to 90 degrees, and other 2 angles are compulsory. Other 2 angles are compulsorily acute angles, less than 90 degrees. So, and in a triangle, we all know there are 3 sides. So, out of 3 sides, trigonometry depends on right angled triangle, right triangle, trigonometry. Therefore, now in a triangle, there are 3 sides. So, maximum 6 ratios are possible. Ratio, something divided by something, something over something, something by something is called ratio. You all know that, right? So here, total out of 3 sides, 6 ratios are possible. See, for example, AB divided by AC is one ratio, or AB divided by BC is another ratio. 2. Then BC divided by AB, or BC divided by AC, or AC divided by AB, or AC divided by BC. 6 ratios are possible. This side divided by this side, this side divided by this side. Like that, 6 are possible. No more possibilities are there. Therefore, there are 6 trigonometric ratios. 6 ratios, 6 trigonometric ratios. 6 ratios of triangle, 6 trigonometric ratios. Now, here I have written full forms of trigonometric ratios. These are the 6 trigonometric ratios: sine, sine, cosine, tangent, cotangent, secant, cosecant. Now, if you observe carefully, sine, then cosine, tangent, then cotangent, secant has cosecant. One trigonometric ratio, then it's cosine, cosine, tangent, then cotangent, secant, cosecant, right? So sine and cosine are co-functions of each other, co-trigonometric ratios. Tangent and cotangent are co of each other. Secant and cosecant are co-functions of each other, right? Now, we cannot use, while solving problems, we cannot use full forms. It will be tedious job, we have to write this all. That's why short forms are used. For sine, sin is used. For cosine, cos is used. For tangent, TAN tan is used. For cotangent, COT cot is used. Secant, sec is used. Cosecant, cosec is used. Short forms are used, right? Now, let's see the definitions of these trigonometric ratios. Which ratio is sine, which ratio is cos, which ratio is tan, right? Now, imagine we have here at C angle theta and here we have angle alpha. Angle B is 90 degree, right angle. C is theta, I have taken C as theta and A as angle A as here at A I have taken angle alpha. Now, here in a right triangle, remember that hypotenuse is a fixed side. Side opposite to 90 degree, side opposite to 90 degree is always hypotenuse. We all know HYP, short form, hypotenuse. Then we have two more sides, opposite and adjacent. Remember that opposite and adjacent are not fixed. Sometimes this is opposite, this is adjacent. Sometimes this is opposite, this is adjacent. We cannot call this as opposite. That depends on which angle theta or alpha is taken with the trigonometric ratio. So this may be opposite or may be adjacent, that depends on angle, or this also may be opposite or may be adjacent. That again depends on angle. I will tell you now. Remember that the definitions, the definition of sine is opposite divided by hypotenuse. Opposite divided by hypotenuse. Definition of cos is adjacent divided by hypotenuse. Tan is opposite divided by adjacent. Then cot. Remember, these three you have to learn, memorize, learn them by heart. Then remaining three you can write. Cot is reciprocal of tan. Cot is reciprocal of tan. So if tan is opposite divided by adjacent, then cot will be its reciprocal. Adjacent divided by opposite. It's reciprocal. Adjacent divided. Sec. Sec is reciprocal of cos. So cos is adjacent divided by hypotenuse. So sec will be hypotenuse divided by adjacent. Then cosec is reciprocal of sine. Sine is opposite divided by hypotenuse. So cosec will be hypotenuse divided by opposite. Remember one important thing. Sine and cosine are co-functions of each other, but they are not reciprocals of each other. Sine and cosine, sine and cos are co-functions of each other. But in case of reciprocal, sine reciprocal is cosec. Cos reciprocal is secant, sec. Cos and sec are reciprocal. Tan and cot, these two are co-functions as well as reciprocals of each other. Tan and cot are tangent, cotangent. They are co-functions of each other as well as they are reciprocals of each other. But in case of other, sine and cos are co-functions, but sine and cosec are reciprocals. Cos and sec are reciprocals. Okay, now this is about definitions. You have to learn these definitions. Just learn these three: sine opposite divided by hypotenuse, cos adjacent divided by hypotenuse, tan opposite divided by adjacent. And remaining three are reciprocals. Tan and cot are reciprocal, cos and sec are reciprocals, sine and cosec are reciprocals. Now, let's go to how to write from this triangle. We will write which ratio will be equal to which trigonometric ratio, right? Now, suppose I am taking sine with angle theta. Here is theta at C. We have theta. Right. Now, if I am taking theta angle with the trigonometric ratio, then the side which is opposite to theta will become opposite. So it is not adjacent. In case of theta, this is opposite. You see angle theta? opposite side. Side opposite to theta will be opposite. And the side which is adjacent to theta, which is attached to theta, that will be adjacent. So it is not opposite. In case of when I am taking theta with the trigonometric ratio, in this case, this will be AB will be opposite to theta, and BC will be adjacent, which is adjacent or attached to theta. That's very important, right? Now we all know that I have already told you sine definition is opposite divided by hypotenuse. So it will be AB divided by AC. This is sine, right? In this case. Now cos theta, we all know that cos definition is adjacent divided by hypotenuse. Adjacent here is BC divided by hypotenuse is fixed AC, right? Then tan is, we all know that opposite divided by adjacent. Tan is opposite divided by adjacent. Then this will be opposite is AB divided by adjacent is BC. Cot is cot theta, sorry, angle theta. Cot is adjacent divided by opposite, that is reciprocal of tan opposite by adjacent. Cot, it's reciprocal, adjacent divided by opposite, that will be equal to, here adjacent is BC and opposite is AB, right? Then sec theta, sec is reciprocal of cos. Sec is reciprocal of cos. Cos is adjacent by hypotenuse, so sec will be hypotenuse divided by adjacent, right? So that will be AC, hypotenuse is AC, AC is hypotenuse divided by adjacent, BC is adjacent, BC is adjacent, right? Then cosec theta. Cosec theta will be, cosec is reciprocal of sine, so it will be hypotenuse divided by opposite. See, sine is opposite by hypotenuse, so cosec will be its reciprocal, hypotenuse divided by opposite. Opposite by hypotenuse, hypotenuse by opposite. These two are reciprocals of each other. These two are reciprocals of each other. These two are reciprocals of each other. Now, so this will be hypotenuse is AC, we know. Then opposite here is AB. This was in case of theta, sine theta. When I took theta as angle with the trigonometric ratio. Now, if suppose I take alpha with the trigonometric ratio, alpha. Suppose I want to take alpha, sine alpha. Now, this opposite and adjacent, they will change. They will not remain same, because now we are taking alpha with the trigonometric ratio at this angle. So the side opposite to alpha will become opposite. Side which is opposite in front, opposite to alpha, that will become opposite. And the side which is attached to alpha or which is adjacent to alpha will become adjacent. See the difference? See the difference? When we took theta, this was opposite and this was adjacent. Now we are taking alpha with the trigonometric ratio. This is opposite side and this is adjacent. That is why I told you hypotenuse is always fixed, opposite to 90 degree, but opposite and adjacent sides are not fixed. They depend on the angle which is used with the trigonometric ratio. Now sine alpha. So again the definition will be same. Definition will not change. Opposite divided by hypotenuse. Opposite divided by hypotenuse. So that will be, this time opposite is BC divided by hypotenuse is same AC. Then cos alpha. Cos alpha. Adjacent divided by hypotenuse. We know the definition of cos is adjacent divided by hypotenuse. This time adjacent is AB. AB divided by hypotenuse is AC. Right? Then tan alpha. Tan alpha. Opposite divided by adjacent. Definition of tan is opposite divided by adjacent. So that will be BC divided by AB. Right? Then next cot. Cot alpha. Cot alpha, we know it's reciprocal of tan, so it will be adjacent divided by opposite, so that will be AB divided by BC. Adjacent is AB and opposite is BC. That's because of angle alpha. Then sec alpha. Sec is reciprocal of cos, so it will be hypotenuse divided by adjacent. Hypotenuse divided by adjacent. So that will be hypotenuse is AC divided by adjacent, here is AB. Right? Okay, then cosec alpha. Cosec alpha. Cosec is reciprocal of sine, that is hypotenuse divided by opposite. So that will be hypotenuse is AC here and opposite is BC this time. This is we wrote the ratios of sides with the trigonometric ratio with different angles, right? See the difference between when we take angle theta and when we take angle alpha with the trigonometric ratio. This is how it. And remember, one more important thing, you have to learn these three definitions only. Remaining three, are the reciprocals of these three. So just learn, memorize by heart. Learn by heart. Sine, opposite by hypotenuse, cos, adjacent by hypotenuse, tan, opposite divided by adjacent. You just have to memorize this. Then remaining three you can easily write. So this is all about the basic of trigonometry. This is very important. If you know this well, then trigonometry will be easy for you. The remaining things in trigonometry will become easy for you. You have to be good at these things. That is very important, right? Now, we'll see the identities. There are some identities. Then there are trigonometric ratios of standard angles. Then we will solve problems from NCERT book, which is used in Karnataka state also. Karnataka state syllabus, NCERT mathematics book is used. Same reader is used. We'll solve problems. But before that, I want to teach you identities and standard angles. Now we are ready to see the trigonometric identities. First identity, I have already written here. The first identity is sine square theta plus cos square theta is equal to 1. We will prove this identity using Pythagoras theorem. Sine square theta, take LHS. This is an important identity used a lot in not only in trigonometry but in other calculus and in physics. Also it is used. Sine square theta plus cos square theta is equal to 1. LHS, what is LHS? Sine square theta plus cos square theta. This is LHS, left hand side, and we have to get 1 as answer. What does it mean? It means while solving problems of trigonometry, if you see sine square plus cos square, sine square theta plus cos square theta, same angle, then that will be always equal to 1. So you can replace sine square of an angle plus cos square of the same angle, you can replace it by 1. Or if you see 1, you can replace 1 by sine square of an angle plus cos square of the same angle, sine square theta plus cos square theta. You can do that. Now, let's write sine. We know that sine is opposite divided by hypotenuse. So, opposite divided by hypotenuse. So, here it is BC divided by AC. BC divided by AC. And because it has a square, so that will be square. Sine, definition of sine, according to definition of sine, sine is opposite divided by hypotenuse. Sine is opposite divided by hypotenuse. Opposite here, opposite is, this is, now we are taking theta. Therefore, according to theta, this will be opposite, this will be adjacent. With respect to theta, opposite to theta will be theta, opposite, and adjacent to theta will be adjacent. So this is not BC, but it is AB divided by AC, opposite divided by hypotenuse. Then, because it has a square here, sine has a square here. And remember, this is important. Sine square theta is same as sine theta square. These two are same, but general practice is we don't write like this, we write like this. Okay, so sine square theta plus cos square theta. What is the definition of cos? Cos is adjacent divided by hypotenuse, right? Cos is adjacent divided by hypotenuse. So adjacent here is BC divided by hypotenuse is AC and square, because it has a square. Now here this can be written as AB square divided by AC square plus BC square divided by AC square, using laws of indices, right? Okay. Then we can take here AC square as LCM, so that will be AB square, numerator will be AB square plus BC square. I hope you all know how to take LCM, right? When denominators are same, then the same will be the LCM, and when we take LCM, the LCM and denominator are divided, and the remaining AC square get divided, 1 is left, then that 1 is multiplied to numerator, 1 into AB square is AB square. Here again these two get cancelled, 1 into BC square is BC square, right? Because plus here. So now we, according to Pythagoras theorem, we know that hypotenuse square is equal to, in a right triangle, square on the hypotenuse is equal to sum of squares of other two sides. Now therefore here AC square on the hypotenuse will be equal to sum of squares of other two sides. So AB square plus BC square. So by Pythagoras theorem we can replace AB square plus BC square. AB square plus BC square is equal to AC square. So this can be replaced by AC square divided by AC square. How did we do that? Using Pythagoras theorem here, right? We used Pythagoras theorem here. Now this AC square, numerator and denominator are same. They get cancelled. AC square divided by AC square will be equal to 1, which is equal to RHS. We got it. This is first identity. Now, one important thing is there. Okay, let's discuss that later. This is you can pause the video and note down the second identity. Now let's discuss second identity. Second identity is 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. Now again take LHS, we'll prove it. LHS is 1 plus tan square theta. 1 plus tan square theta is LHS, right? So we can write it like this, 1 plus tan. What is tan? Tan is opposite divided by adjacent. Tan is opposite divided by adjacent. AB divided by BC. AB divided by BC, and it has a square. So this ratio will also have a square, right? So this can be written as 1 plus AB square divided by BC square. Now we can take LCM. LCM is BC square will be LCM because we don't have any denominator here. So this will be the LCM. When it doesn't have a denominator, BC square will directly multiply with 1. BC square into 1 is BC square. But in this case, these two will get divided. 1 remains. 1 into AB square is AB square, right? Now again, if you observe carefully, we are getting here Pythagoras theorem. AB square plus BC square. AB square plus BC square. AB square plus BC square. And AB square plus BC square is equal to AC square. So AB square plus BC square can be replaced by AC square divided by BC square as it is. Now that will be, we can write it AC divided by BC whole square. So that will be AC divided by BC. What is AC by BC? AC divided by BC is hypotenuse divided by adjacent. Now which trigonometric ratio is hypotenuse divided by adjacent? AC by BC. AC by BC. Hypotenuse divided by adjacent. Hypotenuse by adjacent. If you observe carefully, hypotenuse divided by adjacent is sec. Sec is hypotenuse. So I can write it as sec theta. AC by BC can be written as hypotenuse divided by adjacent, can be written as sec. But it has a square, so this will also have a square. Sec square theta. Now see, we got RHS. This is equal to RHS. We got it. 1 plus tan square theta is equal to sec square theta. This is the second identity. Now let's go to the third identity. Third identity is you can pause the video and note down the relations. And the third identity is 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to cosec square theta. Now, we'll prove this. Again, take LHS. 1 plus cot square theta is LHS, right? 1 plus cot square theta is LHS. 1 plus cot square. So we can write 1 plus, we know that cot is reciprocal of tan, adjacent divided by opposite, adjacent divided by opposite, adjacent divided by opposite, that will be BC by AB, BC divided by AB, but it has a square, so this will also have square. Definition of cot, adjacent by opposite, adjacent is BC, opposite is AB, therefore opposite divided by AB, BC divided by AB, then that will be 1 plus, this can be written as BC square divided by AB square, again using laws of indices, right? Laws of indices. Then we can take AB square as LCM, so this will be again AB square plus AB square get cancelled, so BC square is left. We are again getting here Pythagoras theorem, AB square plus BC square, right? AB square plus BC square, which is equal to AC square, so we can replace it by AC square divided by AB square. Right. Now that will be, we can write it as AC divided by AB whole square. Right? AC divided by AB. What is AC by AB? AC by AB. Hypotenuse divided by opposite. Hypotenuse divided by opposite is cosec. AC divided by AB. AC by AB. Hypotenuse divided by opposite. Hypotenuse divided by opposite is cosec. So this can be written as cosec theta, and this has a square. You see, here we have square, continuously we have square, so this will also have square. So we got our H's. This is the third identity. 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to, so we proved 3 trigonometric identities, 3 trigonometric basic identities in trigonometry, very important. Now, using these identities, we can make some more identities. For example, I'll show you. These identities are used in other ways also. See, for example, we already saw sine square theta plus cos square theta is equal to 1. Now, do some maths here. Transfer cos here. So that will become equal to sine square theta is equal to 1 minus cos square theta, right? That means 1 minus cos square theta is equal to sine square theta. While solving problems, if you see sine square theta and required or needed, you can write it as 1 minus cos square theta. Or if 1 minus cos square theta is there, you can replace it with sine square theta. Or if you transfer sine here, then it will be here cos square theta as it is. Take this sine here, so that will be equal to 1 already there, 1 is already there. This plus sine square theta will go there and become minus sine square theta. One more identity is formed. So while solving problems, 1 minus sine square theta can be replaced with cos square theta, or cos square theta can be replaced with 1 minus sine square theta. The same way, 1 plus tan square theta, the second identity, is equal to sec square theta, right? Take 1 here, so it will be tan square theta is equal to sec square theta minus 1. You can do this. Or take tan square theta there, so that will become 1 is equal to sec square theta minus tan square theta. Oh, we have one more for 1, right? We have one more identity for 1, that is sec square theta minus tan square theta is equal to 1. Sin square theta plus cos square theta is 1. Sec square minus tan square is also 1. And we saw one more. 1 plus cot square theta. 1 plus cot square theta is equal to cosec square theta, right? So for this, if you take 1 there, so it will be cot square theta is equal to cosec square theta minus 1. Or one more is there, you can take cot there, so it will be 1 is equal to cosec square theta already there, minus take cot square theta there, so that will become minus cot square theta, right? Plus cot, if you transfer here, that will. So we have here these three then these three, then these three. These are basic trigonometric identities. Using these, we can solve problems. Then we have standard angles with trigonometric ratio like tan 0, sine 0, cos 0, sine 90, cosec 30, 0, 30, 45, 60, 90 degree. These angles are called standard angles. We'll see that also in our next video. Now I hope you enjoyed the video and I hope you will get a lot of benefit from this video, especially those who have passed grade 9 and entering into 10, and those who are going to write board exam of 10th standard, also those who are in first year or PUC second year. If you are not good at trigonometry, like you have any doubt, you can watch this video and get the benefit of this. Thank you for watching my video. Stay home, stay safe. We'll soon meet with my next video. Thank you.